Okay, so in this video, we're going to talk about more characteristics of quadratic functions. Quadratic graphs either have a minimum or maximum value. So a minimum value is like a U, and a maximum value is like a mountain. I like to think of minimums as kind of like a bowl, so like the very bottom, I can keep putting more on top. And I like to think of mountains or maximums as like mountains, where if I put more on the top, it can't go, it's just going to slide right off. Okay. So you will either have a maximum or a minimum. You can only have one. You will not have both in quadratic equations. And it always occurs at the vertex and is the y value of the vertex point. A quadratic graph has a minimum value if it opens up and has a positive leading coefficient. That means the number in front of the x squared is positive. It has a maximum value if it opens down and has a negative leading coefficient. So it has a negative number out in front of the quadratic. Remember, domain of a function is all the possible x values, and the range is all the possible y values. A function is said to be increasing if it has a positive slope between two different points. So if it kind of looks like this, it's said to be decreasing. Oops. If it has a negative slope between two different points. So it kind of looks like this. Okay. So example 1 wants me to find the maximum or minimum value of the function. Remember, f of x is just notation on how to name it. And then it wants me to give the domain, the range, and where the function is decreasing and increasing. So let's go to Desmos. I'm going to type in my equation. Oops. Remember, when I'm working on fractions on Desmos, I have to arrow out to get out of the bottom of the fraction. To do the exponent 2, I want to do shift in the 6 key for the little caret looking button. Okay. Then I get my graph. I am going to copy this on my paper. I'm going to notice that it has a vertex at 2, -3, and then almost a half, -1/2, and 4.5. So I'm going to copy that over. And if I go back to the camera, so it's U-shaped, so it has a minimum value. And it's, remember, my coordinate here is 2, -3. So my minimum value is always the y value of my vertex, so it's going to be y equals -3. Okay. Then it wants me to give the domain and range of this function. Notice these arrows are going up and to the left and right forever, so it's going to, eventually it's going to be very slowly, but if I go back to my graph on Desmos, I go up, see it keeps going more left and right. That means it's going to cover every possible x value. Another way to think about domain is, what can I plug into this function? So is there ever a number I cannot plug in here? So I could plug in 1 if I wanted to. I could plug in 1,000,000 if I wanted to. Million's not going to give me a nice number, but I can plug it in. So domain here is all real numbers. Okay. My range is all of the possible values I get out of the function. So if I go back and look at this graph, my lowest point, remember, was y equals -3, and then these arrows go upward forever. It's going to keep going up. So my range is y is greater than or equal to, because it goes up, and it includes -3. Remember, the line means to include, the greater than means going up. Okay. This one wants me to find the maximum or minimum value of this graph, and then to identify the x-intercepts of the function and describe where it's increasing or decreasing. Notice this notation is given to me in intercept form. So that'll help me when I'm looking for my intercepts. Okay, let's go fix my graph so I'm looking back at the origin. So this is what it looks like if I scroll down a bit and I click on my vertex. It's at -1, +8. And then if I look, these x-intercepts are nice. -3 and +1. So I'm going back to my paper. And there is my graph. So my vertex was -1, 8. And I was crossing here. This one is 1, 0. And this one is 3, 0. Right? Then it wants me to say where the function is increasing and decreasing. Remember, increasing is a positive slope. So it is increasing. And if I look, all the x values that I plug in on the left side of my vertex make it have a positive slope. So it's increasing x less than -1. I don't include the -1, because it is part of my vertex and it's a turning point, and turning points are never included. Then if I want to take a look, then I also want to find where it's decreasing. So going down, which is on the right side. I like to think of the symbols as this one means left, left for less, and this one means greater than for right. Not as easy. I mean, not as nice as left, but the less than symbol kind of looks like a capital L. Less starts with L, left starts with L. So, okay. And then I will just write my intercepts again. That was at 3, 0, and 1. That's not a 0. Okay. So what I want you to do right now is pause the video, take a few minutes to work on the 2 on the back on your own, and then when you feel like you're ready, unpause the video and then compare your work to mine. So I'll give you a few seconds to pause. Okay. This one gives me an equation in standard form. So I want to go ahead and graph this. Okay. I'm going to scroll down to where it's at. This one is going all the way down to -14 for the y value and to -2 for the x value. On my graph on my paper, I'm going to write that my y scale is by 2. And then I'm going to count by 2s when I go to graph it. So we can go look at my paper. So I have 2, 4, 6, 8, 10, 12, 14. That's where my vertex is. And then go back and look at Desmos. It's crossing at a little less than 1 and a little more than 4.5. Okay. My vertex was at -2, -14. Oh, you're not on my paper anymore. Okay. This one wants domain and range and where the function is increasing and decreasing. Was number 1 asking for increasing and decreasing? It was, my bad. So the domain and range here is domain for all quadratic equations. So anything that has the highest exponent as an x squared will always be all real numbers. My range looks at my maximum or minimum value. In this case, I have a minimum value and it's -2. So those are those two pieces. Range goes with y and -2 is my minimum. It includes the y value and this one is going up, so it's greater than. Then if I want to take a look at increasing, remember increasing is going up, so positive slope on the right side of the x. This is going to be x greater than, because it's on the right, -2. Then I want to do the same thing for decreasing. So I want to look at the slope going down, which is on the right side. Which gives me x is less than -2 because it's on the left. Number 4 wants me to find the maximum or minimum value of this, and then to identify the x-intercepts of the function and describe where the graph is increasing or decreasing. So I want to go back to Desmos. I am going to type in my equation. Oops, I wanted a parentheses, not a 9. I'm going to click the home button to see it. This one has my vertex at 1, 3, an x-intercept at 2, 0, and another one at 4, 0. Okay, so we're going to go back and look at my paper. I don't know why it takes a second to load. So this one has a high point, so my maximum value. I forgot to say my maximum value or my minimum value on the last one. My maximum value here is the y point, which remember our vertex was 1, 3. So my maximum value here is y equals 3. Then it asks for the x-intercepts. Notice those are opposite the values inside parentheses. So instead of having a +2, I have a -2. Instead of having a -4, I have a +4. Okay. Then it also wants to know where it's increasing and decreasing. Increasing is going up. Has a positive slope on the left side this time, so it is x less than 1. Next, it wants to know where it's decreasing, which is happening on the right. So x greater than 1, because remember greater than means right. Okay, so as I was solving these, I noticed I forgot some things to do. This one, I forgot to say my minimum value because it has a low point. My minimum value here is the y value of the vertex, so y equals -14. And then I forgot to do something on number 1. I forgot to say where it was increasing and decreasing. So increasing is where I have the positive slope, which on this one is on the right side. So I have x greater than, you always use the number from your vertex here, so 2. And then I also need to find where it was decreasing. And it had a negative slope on the left side. So this is x less than 2.